When we're talking about a dilation, we're talking about resizing an image. So anytime you edit a picture on your computer, when you drag the corner of it and you make it bigger or smaller, if you shrink or you enlarge the picture, you're performing a dilation. You might also be familiar with this at the eye doctor. They put drops in your eye and it dilates your pupil. It means it's growing really or shrinking really. It doesn't really matter if it's changing size at all. It's a dilation. A dilation is always described by a scale factor, and that's the number that's being multiplied by the original coordinates to find the coordinates of the image, the new coordinates. Right, so the scale factor is always being multiplied times the original coordinates, and that tells us the new coordinates. It's really as simple as that. It's going to get bigger or smaller depending on what that number is. If it's a number that's bigger than 1, then the numbers are going to get bigger. The coordinates grow, and the picture gets bigger. If the number is smaller than 1, if it's a decimal, then the image is going to get smaller because all the coordinates will get smaller. We're just going to multiply all the original coordinates times that number, and that gives us the new coordinates, the coordinates of the image. On this one, we're working backwards. We're trying to figure out what happened to this red one, the original A, B, C, to turn it into A prime, B prime, and C prime, to turn it into that new blue triangle. Okay, so that's what this is saying, going from the pre-image of ABC to A prime, B prime, and C prime. What's the scale factor? How many times bigger is this? The easiest one to look at is definitely going to be these positive numbers. It's going from A, which is 2, 1, to A prime, which is 4, 2. So looking at those two. Or we can look at point C. That might help too. You can see that those are doubling. You're multiplying that times 2 to get up to that, and that times 2 to get up to that. Same thing with C. 2 times -3 would give us -6. 2 times -2 would give us -4. So here the scale factor is a +2. That's getting 2 times bigger. The next question saying if A prime, B prime, and C prime was the pre-image and ABC is the image. So basically it's going now from the blue one to the red one. It's starting out with the blue, going to the red. What's the new scale factor? So it's going backwards from what it started out as. It's going from 4, 2 to 2, 1. That's shrinking. That's being multiplied by a scale factor that has to be less than 1 because those numbers are getting smaller. It's being cut in half or multiplied by a scale factor of 1/2. The next two examples, we're looking at straightforward, change this original shape, ABCD, into a new smaller or bigger shape using that scale factor. We know that's going to get bigger because it's a scale factor that's bigger than 1. So first off, just plot the original points. Alright, so that's our original figure in purple. Now we're going to multiply each of these original coordinates, the x and the y, times our scale factor. So 0, 0 is not going to change. It's going to stay at 0, 0 because 0 times 2 is still 0. So neither one of those coordinates change. For letter B, we're multiplying 2 times 2. For coordinate B, we're multiplying 0 times 2. That part doesn't change. But for the y coordinate, we're multiplying 2 times 2. That will change. That'll give us 0, 4. So for letter B, we're going to plot that at 0, 4. That's going to go up to here. So it went up from 0, 2 to 0, 4. It doubled its distance away from the origin. So that's the second way to see this. We can see this as an image that's growing. Like this line is growing, it's doubling in size. Or we can see this point as doubling its distance away from the origin. 3, 2 will change to 6, 4. We're multiplying both of those times 2. So 6, 4 is here. And again, it's doubling its distance away from the origin. And 1, 0 will end up at 2, 0. So our final point will be at 2, 0. Alright, for the next one, we have a scale factor of 1/2. That means we're multiplying times 1/2. The numbers are going to get smaller. Multiplying both those times 1/2, we get -2, -2. Multiply 0 times 1/2, it's still 0. 4 times 1/2 is 2. And then we multiply C's coordinates by 1/2, we get 3 and -2. So I'm going to plot the original one in purple again, and the new smaller one in blue. And you can see that each of these points got closer to the origin. Each of them actually cut their distance from the origin in half. Anytime we have a scale factor that's less than 1, the points are going to move closer to the origin. The overall shape is going to get smaller.